Hello, welcome to this lesson of Mastering Java, and here we are in lesson number 25. We're going to learn about logical operators, and this is basically going to let you create more complicated if statements. It's very useful and actually really easy to understand. Let me go over what they are up here at the top, and then we'll just go through some examples here, and then you can work the exercise yourself and get a little practice. When you see a double ampersand, that's an operator that means logical and. The double vertical bars, which is near the backslash key on most keyboards, is a logical OR. And the difference between these are very easy. If I'm evaluating an if statement, maybe I want to evaluate something that's more complicated. Then I have two things going on. If I want the if statement to trigger, A and B must both be true. Normally in if statements we're testing one thing at a time this far, but we may actually want to test two things, and both of them have to be true in order for the logical AND to trigger true, or to return true. For the OR, logical OR, it means either one of them can be true, A or B. That's what logical OR means. It's just like it means in the English language, one or the other. That's what it means. And if either one of these things are true, then the if would then trigger as true. Then we have something called logical NOT. This has a weird thing I've typed here. It means you're inverting the state. In other words, when you NOT something, you're changing it from true to false or from false to true. So we've been using it up to this point in terms of not equals, for instance. We can ask if x is not equal to 3, and that's kind of what's going on there in terms of the NOT. And then finally we have this caret symbol, and that's a logical XOR. It means A or B, but not both. So in other words, it's A or B, but in this case, for the regular OR, A could be true or B could be true. If both A and B are true, then of course it logically satisfies a regular OR. But for an XOR, which is called an exclusive OR, it means A or B, but not both together. So I know this kind of thing can seem a little bit challenging at first or difficult to understand, but let's just dive through a couple of quick examples here, and I think you'll find that every one of these is very easy to understand. So let's create an integer called A, and let's just leave it like that. And let's create a Boolean called B. And we'll set the Boolean equal to true. Actually, let's don't do that. Let's just set it like this, okay? And then we'll say A is equal to, let's say, 10, and B is equal to true. Now I'm setting these equal to these values totally for no particular reason. I'm going to do some if statements here to show you how to evaluate ands and ors and nots and so on here. Let's go and start with the easiest thing that we already know how to do. Let's start with something that we have already done before. So let's do if A is equal to 10. We've done this many times before. Then let's print the following statement. System.out.println like this, and inside of here I'm going to do success. This is just a statement that prints only whenever the if statement is triggered, because I'm basically just want you to know when the if statement is true. So we know that 10 is the value of A, so we know that this is going to evaluate true, so we know that this particular statement is going to print out fine, and it says success, and that makes total sense. So let's don't go in order. The easiest one to understand, I think, is this one, logical NOT. We've done that before, but let's just make sure. Not equals. Okay, when you put a not in front of equals, it means it inverts it. It changes its meaning to the opposite sense. So instead of looking for equality, you're looking for not equal. All right. So in this particular case, when we run it, nothing's going to happen because it's just saying if A is not equal to 10, then do this. All right, but in this case, A is actually equal to 10, so we skip over the loop. Now, if I change this to anything else and run it, then we actually trigger the loop, because in this case, A would not be equal to 10. All right, not be equal to 10. So let's go ahead and change it back. That's basically the extent of the not. It's just inverting the meaning of what you're trying to do. All right, now the next one that I want to work on is AND. When we look at A and B, both things have to be true in order for the guy to return true. So we already know right now that since A is equal to 10, we're going to get our success here. But what if we want to know something different? What if we wrap this guy in parentheses like this, and then we put and by double ampersand. We put another set of parentheses, and we say B is equal to true, like this. So what this is saying is, if A is equal to 10 and B is equal to true, both of them have to evaluate back to true, then I will go and execute what's in the if statement, which is a success in this case. If I change one of these things, and change this to a 4, what do you think is going to happen? It's not going to go into the loop, because even though B was true, A did not evaluate into true, and both of them have to evaluate to true for an AND statement. All right, let me move this back to 10. And again, you can see the same thing here if I change this to false. So I've changed B to false. Again, nothing happens because the first one evaluated true. The second one was not true. So let me go back in here. And let's just verify that we run it. Everything works fine because both of them were true. So that's A and B, right? And you could have other types of things in here. Maybe I want to say A is greater than or equal to, 7. And you have to look at it individually. Is this going to evaluate true? Well, yes, 10 is greater than or equal to 7, so this should be true. This should evaluate to true, all right? So in this case, it should go ahead and trigger the guide. The double ampersand is taking both things, and both of them have to be true. We wrap them in parentheses to denote that the entire thing in here has to be true, and this entire thing in here has to be equal to true. And this is typically how you would see it done. All right, now let's look at OR. Right, which is this one right here, or. In this case, let me go and change this to 10, like we had before. And let me just save and run it, make sure everything's working fine. So we'll change the AND to an OR. So all I did was put the two vertical guys here. What do you think is going to happen? OR means this one could be true, or this one could be true. If either one or both of them happen to be true, then it successfully triggers the if statement. So that works fine. So now let me change this true to a false. All right? And you can see by running it that the if statement is triggered. So when we do an OR statement, it's really either one of these guys can be true. And if either one of them is true, we trigger the condition. In this case, this one is true. This one is false. All you need is one of them when you're dealing with an OR. Right? And I can show you the other way. Change that to true and change that to 0, let's say, and you will see that the if statement will continue to trigger. This one is false. This one is now true, so we do trigger our statement there. All right, let me move this back to 10, and let me show you the final one here, which is called the exclusive OR, XOR, which means A or B, but not both of them. So let me change this to 7. All right, so how do you think this is going to evaluate? With an XOR, we need to change this to a caret symbol like that. This one, A is equal to 10. Well, that's not true. So this evaluates to false. This one evaluates to true because B is equal to true. So here we have false and true, but this is an exclusive OR. So that means either one of them, but not both. So here we get success because only one of them needs to be true, right? So let me change this to false. And let me change this one to 10. And I will show you that in this case, this one evaluates to true because A is 10. This one evaluates to false. Everything's great. We still get a success. So for exclusive OR, it's A or B, but not both, right? So let me go and evaluate and change this back to true. So in this case, A is 10, so that's true. B is true, that's also true. We're doing an exclusive OR, and then the if statement is no longer triggered anymore. This is just one of those logical things. It's not used as much as AND or. It's called exclusive OR, A or B, but not both. By and large, 99.9% of the time, what you're going to use is AND, OR, and NOT. And you're going to almost always use them when you're evaluating if statements. You may have, if the grass is green and my age is greater than 10, then do the following. And I have multiple conditions I need to meet. If all of them need to be met, then I need to use an AND. If just one of them needs to be met, I can use an OR. And also in this case, I only have 2 conditions, but I may have 3 or 4 conditions, each one separated out. Let me just show you really quickly. Let me create, let's do something weird like character. Jason, we'll just call it Jason. Okay, and let's set Jason equal to the letter lowercase r, because it's a character variable. All right. So let's change it to and. Right. So if A is 10, B is true, and then I can go and I'll open another set of parentheses. Jason double equals r. So if all three of these are true, if this is true and this is true and this is true, then what do you think will happen? Just success. But let me change the value of Jason, for instance, to t, so suddenly this one's false, the other two guys are true. What do you think is going to happen? Nothing at all, because for an and, every single one of the arguments has to be true. For an or, any one of them just needs to be true. So that's kind of a lesson in logic, and it's also a lesson in programming at the same time. There will be cases whenever you're going to need to be using these things. So keep it in mind when you write your programs. When you have multiple conditions, you can spell it out in terms of logical and, logical or, logical not, and sometimes exclusive or.